Is it? Oh, it is working.
So now we have Alan Coopersmith telling us something about how Solaris does security.
Okay, well, so sort of following on from the previous talk, they'd mentioned how it would be nice if the X server could run with less privileges. For those who haven't seen it yet, an exploit was released over the weekend that lets you get trivial root access on Solaris, Linux, by the fact that if you set certain environment variables, you can then when we call into the dbus library to find your input devices, dbus says, oh, I'll just fork off this new process for you following these environment variables that the user set. The X server had no way of knowing that dbus was doing this down in its API. The X server is a very large and complex process that calls lots of these APIs. We can't always control what they're going to do, so we'd really like to run it with less privileges. This has come up over the years, and it's been discussed in several previous XDCs. I know there are issues on Linux with why it can't go completely rootless. OpenBSD has a privilege separation model that maybe we could pull some stuff from that into the mainstream. Okay. So yeah, I just thrown together a few slides on what we do on Solaris to see if any of what we do could also help in the general case. So that's so yeah. Hopefully this will be quick since I know I'm between you and your lunch. Yes, death or loss of skiing privileges, because death isn't bad enough. So Solaris, we've actually shipped a number of X servers over the years, and we've left out the ancient history here, like X11 news, which is what happens when you tell a bunch of developers, we need to combine X and news in the worst possible way, and they take you way too literally. So Solaris 2.3 through 10 include XSun, which was forked from the old consortium sources. I think they started with X11R3 or so. By the final release in Solaris 10, it was up to X11R6.6. We also sadly included the Xprint server based off these sources, and then later XVFB and XNest. Solaris 10, which came out in 2005, and later releases include just Xorg from upstream. And we learned our lesson. We didn't fork it. We just do like all the Linux distros do. We take the upstream, we unpack it, apply some patches. Solaris 10 is Xorg 1.3. Solaris 11 is Xorg 1.10, since that was current when we came out last year. Not on this slide because it's not officially announced yet. Solaris 11.1 coming out in a few months will have 1.12, since 1.13 hadn't finished its merge window when we had code freeze. And so we shipped the Xorg, Zephyr, XVFB, and XVNC based sources. XVNC, we use the Tiger VNC, and we actually borrow a lot of patches from Fedora's Tiger VNC packages to build the current Xorg. So XSun was set GID root on Spark and set UID root on x86. Xorg is set UID root on both platforms. XVNC is set GID root. The other ones we have not given automatic privileges to, which actually caused some problems in past years. So this is what bits we set. Why we did it. Originally Solaris used the transport endpoints in temp. We made those only writable by group root so that you couldn't create a Unix domain socket or named pipe in there and intercept the X connection before the X server actually had a chance to start and use it. We've now moved to the sticky bit because that kept things like the non-set GID XVFBs from running if you had run a normal XSun server. GID 0 was also used to control power management, and there's a priority boost mechanism where the window that has focus, we actually just give it a little boost to its priority so that you have a more interactive response. And that's all managed by the X server through use of group 0. And on Spark, that's all EXA needed because kernel frame buffer drivers did the rest for you, all the privileged device access. x86, though, we have this user space driver mechanism just like Linux where you have to map the memory apertures and do the IOPL setting to get to the PCI bus registers. And now with Xorg, even on Spark, we've had to add root access for things like rotating the log files. If we were going to make a rootless X server, we could easily make a new varlog x11 directory that the X servers could write to that doesn't require root like varlog itself. But we haven't because we haven't solved the other problems yet. And with Xorg, we have Spark drivers that rely on kernel drivers for device access like the old style did. But the latest ones we've ported, like the Matrox driver, now use libPCI access just to cut down the porting effort. So right now on Solaris, when you start X server, it's set UID root, so it starts up with root privileges. It creates a named pipe in a directory that only root can read and write, and uses this to communicate with GDM. So your X server comes up, the GDM login screen comes up, and GDM asks the user to log in. Enter your smart card PIN, your password, your Kerberos passphrase, whatever. When you successfully authenticate, GDM then writes a number of key value pairs to that pipe to say, okay, you've now logged in as UID 123, group with group ID 10, home directory is home Allen C, whatever. And Xorg actually then does a set UID, set EUID, set GID to set all those and gives up the, because it's already opened the devices, it's already set the privileges it needs. So then it can run most of the rest of the time as just the user. But it has to use the POSIX saved set ID mechanisms to be able to get back because of things like server regeneration, where you have to close all your devices and reopen them, as well as VT switching. And so input devices, Solaris doesn't need root privileges to deal with those because the kernel takes care of it for us. There is a list of files that get choned to the user who logs in on console, which was originally just dev console. Now it's a link to the currently active VT. And so when you log in, GDM chones all these devices to you, and then our daemons for creating new /dev files for hot plugged devices will check that and chone those devices as well. So if you hot plug a mouse, it says, oh, Alan C is logged in on console. I'm going to chone this mouse to him so that we don't need root privileges to open the common input devices. Excuse me. And then on VT switch, we've also taken that information that GDM passed us, used an octal to set it to the kernel so that the kernel knows what user owns each VT. And on VT switch can take care of choning all the devices to the user who owns the VT you're switching to, so that we can close the devices in the old X server as the old user, reopen them as the new user, and when it works, transparently hand off ownership again without needing root privileges. So, and yeah, I really didn't have that many slides. So yeah, I have actually put slides in the presentation with links to the sources and documentation if anyone wants to see it. I still need to add some more links, but I'll be posting these on the page for my talk. I encourage everyone who's giving a talk this week to post your slides on the page in the wiki for your talk for future reference. But yeah, mostly I wanted to open a discussion on what is left to make it possible to run Xorg without root privileges on more systems. So I don't know if anyone has questions or suggestions, comments, or is just ready to go to lunch since it's 1225. So Keith had said that on Linux you are running successfully without root, obviously requiring devices with KMS.
We also need to change the X server so that it can actually load video devices without having to do the IOPL. So right now there's an IOPL system call to gain access to the I/O ports in the devices,
right.
And the server does that without, because the driver can't tell it what it needs. There's small hacks to make that work. But other than that, with a KMS X driver, there's absolutely no root required for the X server, and we've run a bunch of that quite successfully. And right now we have obviously Radeon, NVIDIA, and Intel drivers that don't require root access, and we have a distribution or two that's showing that.
Right.
The trick, of course, is to know whether you need root access before you start the X server.
Yeah, and unfortunately with our current auto configuration, we probe the PCI bus to look at all that and then figure out which drivers to load.
Yeah, exactly. So it's very difficult to know a priori whether the X server needs to run as root, and so it's pretty easy for me as a distributor to say, well, I don't care about anything other than Intel, NVIDIA, and Radeon, and just not worry about it. But
if you're a distributor of a consumer OS,
Yeah,
if you're
exactly.
going for the enterprise space, then you care about things like Matrox that live in server engines,
Right.
service processors.
Exactly. And so we need to, obviously, ideally, what would be nice to have happen would be the other thing is that we are able to do things like use dumb frame buffers still. And if the kernel has support for dumb frame buffer on a device, that's often the best option these days in terms of performance and stability in any case. And so it's often better to use that. So it may be the point where we marginalize enough of the older devices that we just don't need to worry about them anymore, and we can run the X server as non-root and just use those in basically Visa mode and do a simple dumb frame buffer access to those. It does obviously limit a lot of functionality though. We'd lovely if other video devices vendors would step forward and actually provide competent support for their devices, but yeah.
This may actually happen pretty soon for a totally different reason. That's called secure boot.
Yes, that's actually going to block the VESA driver from working on those. UEFI, I thought was incompatible with VESA.
Yeah, but also Matrox and some of the other drivers that currently still live in user land can't live there anymore with secure boot. So, but I think we already have a kernel mode setting Matrox driver in a very early stage.
And we may be able to, as they'd suggested, move some of these functionalities out of the X server into a probe my PCI bus and find the right device program, so that you don't have to have the entire X server running for the whole length of the program with root, just a quick startup. Run scan PCI as a separate program or something.
Well, you don't need root just to scan the PCI bus without writing to the config space. Normally, you can. The information is public on the machine, so you can allow a user land process to just read the config space.
Okay.
As long as you don't want to program it. And yes, on OpenBSD, using the Visa framework for driver in the kernel, it's also really easy to run the X server without privilege. There are a few other little stuff that needs patching, like the fact that the log file is written in a directory that is not writable by anybody but root, but this is easy to fix.
Yeah.
At least for a prototype demo. For something that's more general, I don't want to use syslog for the Xorg log messages and creating a log file in the user's home directory in a clean way is not that easy, but well, it's doable.
Well, and the problem with doing it in the user's home directory is, at least most systems, you start the X server first, and then the user logs in to the graphical login screen, so you don't. Otherwise, you're dumping it in root. But yeah, we could do something simply like making the X server run as group Xorg and have only Xorg write access to the log directory. anyone else, or are we all ready for lunch?
Looks like people are ready for lunch now.
Okay,
So, yeah, have a nice lunch, and we will see each other back here at 14:30, 2:30. One quick note, you can leave your equipment in here. The door will be closed, and our trainee, Gerhard, are you here? Okay, he will be in the room so that you can get back in.
Hey, but I think she said 14:30, but I think it's 14.
14? Yeah. Yeah, right. It's 14. Sorry. Yeah. Yeah, we can.